Hello everyone. Today I'm going to have a very short demonstration about the electric motor, particularly making a brushless DC motor. As far the electric motor goes, usually we have DC motors just like this one, as you can see. It's called brush motors. So I can change the direction by also changing the direction of a magnet. So this is one type of electric motor. So it has brush over here. They call it brush DC motor. Another type also is just like the same one. I can show you over here the next one, which is this. So I have to find the wire first. Okay, you can see the movement of the rotor. This one also, it has a brush, so they call it brush DC motor. And I can show you several types, but my purpose is to teach you how to make brushless DC motor. As you know, we have several types of brushless DC motor. One type is inner runner. This one is inner runner, the one you also can see here. So it means that the rotor moves here, or permanent magnet is connected over the rotor. So the rotor moves. So here the rotor is inside, and it moves. It contains several permanent magnets in it. The other one also I would like to show you is the auto runner. That one was inner runner, but the next one is auto runner. Today my whole concentration is going to be focused on auto runner. So let me show also the performance of this one. So here the rotors is outside. The permanent magnet is inside, so it's a stationary electromagnet which doesn't move, is inside, but the rotor is outside. It has permanent magnet. So usually most of the hubs DC motors, they usually use for bike is this type. Here is another one, and the number of permanent magnets over here is more than that one. So you can see this, the speed is very high. It contains rotor, which is permanent, and or electromagnet is inside, and the permanent magnet is outside. So let me first to show you how it moves, and then tell you how I can make it. See? Okay. Let me tell you how the instruction is. I'm making a brushless DC motor by using two plastics. As you can see, these are the cans I have used it here. So in this one, the electromagnet is constant, so it doesn't move. So I have to make actually electromagnet over the body of this. First we find out a plastic like this, and then we measure the distance around this bottle. For instance, over here I measured this one, it was 14 centimeters, so then I can put 40 screws on it. And also this one, which is the outer runner, I have to put magnet inside this one. So then I put it in like this. So this is constant, and this one then moves. So first I try to make the electromagnets. In my experiment, I used 24 meters of these wires, which is 0.16. 28 meters, which is divided by 2, will be 14 meters. So it's parallel, it's two wires. I start to wind, I start from somewhere like here. I start to wire first clockwise. 1 meter of this double wire will be wired clockwise. Okay? And after that, then I try to wind counterclockwise. So each one has 1 meter, one double meter actually. And the last one will be counterclockwise. So the first will be clockwise, and the last one will be counterclockwise. Okay, this is for electro motor, which I use a screw actually and wire. All of these wires should go inside this box. I need a beam such like this. So this beam should have hole in it. I put wire in it. Then I use the other one. So I put permanent magnet around this one, connected like this one. I put the magnet, and the magnet should be connected in such a way that, first of all, it should be odd number, even numbers. If it's odd numbers, you can put together. So this should be N, the other one should be S, and the last one should be S. So if you do like this, they don't repel each other. They connect and they attract each other. So they remain around this one. The last things that I need a, according to this paper, you can see this picture, I need a controller. This controller over here is a H-bridge or Hall effect transistor, which is L298N. So my main controller is this one. So as soon as the magnet strikes this one, it gives pulse. So it gives different direction. When it gives different direction and the pulse goes to this transistor. So this transistor, which is field effect transistor, is 5864. So the gate will be triggered, and also the drain will have current. So the magnet over here, the electromagnet, will be activated. As soon as this one activated, then it will have a repulsion action. So the repulsion action means that they are going N and F, N and S, something like this, to N, reject, to S, reject. So when they reject each other, and the movement starts. Here you can see the complete circuit over here, and this is the map. You can use this one and make a DC brushless motor. Thank you.